Very good morning, dear friends. Myself, Dr. Vikrant Sudhakar Palekar. I am working as Assistant Professor in Gokhale Education Society's Arts, Commerce and Science College, Jawar, Palghar. Welcome on the lecture series on the topic Chemical Thermodynamics. This is the fourth session we are doing. Till now, we have understood different basic terms related with the chemical thermodynamics. What is system? What is surrounding? What are the types of the systems? Then what are the different processes, that is the reversible process, irreversible process. And in the last session, we have tried to understood the very basic terms, which is heat. And we have come to know that heat is the form of thermal energy which is being associated with the system, and it generally flow either from system into surrounding or from surrounding into system. So based upon that, it can have the different sign convention. And we also understood the important term, that is work. When heat flows inside the system, it results into the generation of work done. So that will be work done on the system, maybe due to the compression, or work is done by the system, maybe due to the expansion. So based upon that, it can also have the different sign convention. So these are the basic terms. So in this particular session, we are trying to understand the very important basic law of thermodynamics. Also in the last lecture, we have seen zeroth law of thermodynamics. So in the zeroth law, we have come to understand when initially at two systems will be in the thermal equilibrium, when the third system is being introduced, so that third system will also be in the thermal equilibrium with the second system. So ultimately, the three systems will come into the thermal equilibrium due to the flow of heat from one system into another system till they achieve the same temperature. So first law of thermodynamics is the very important law which basically talks about the internal energy. So in the first law of thermodynamics, there is a very important term which is being involved, that is being called as a internal energy. So we will try to understand what is basically the concept of internal energy. So as we know that a system is fixed state and has definite and constant amount of energy, that is known as internal energy. हर एक सिस्टम की खुद की एक इंटरनल एनर्जी रहती है, बिकॉज एवरी सिस्टम इज हैविंग सम मैटर and that matter is having some amount of definite amount of energy due to the atoms and molecules which are present. So the thermodynamic system containing some matter has definite quantity which is being called as a internal energy. Remember, whatever the matter which is present inside the system which is being called as a internal energy. सिस्टम की खुद की जो एनर्जी रहती है उसको हम लोग क्या बोलते हैं, इंटरनल एनर्जी. सो दैट इंटरनल एनर्जी may be due to the rotational energy, may be due to the translation of the molecule which results into the translation energy, may be due to the vibrations of bond, that may be in the form of vibrational energy, may be due to the different types of bonding which is present inside the molecule, that will result into the bonding energy, may be the electronic energy. So whatever the electrons which are present inside the molecule, they might result into the electronic transition. So that particular energy will be in the form of electronic energy and nuclear energy. So these are the different forms of energy which are associated with the matter, and that will result into the definite amount of total energy of the system. So internal energy, we can say it will be sum of translation energy plus rotational energy plus vibrational energy plus bonding energy plus electronic energy plus nuclear energy. Basically, you must know that the internal energy, in the earlier classes you have some studied that it may be the sum of kinetic energy plus potential energy. Okay, so these are the two forms of energy, but here the internal energy, we can also say it will be sum of different form of energy which are associated with the system it is being denoted by the sign E. Remember, it is a state function. So it is not a path function, it is a state function. Remember, internal energy is a state function. So internal energy is denoted by the sign capital E, or it may also denoted by the sign U. In the physics, basically they denote internal energy in the form of U. So these are the two symbolic representation which are used to represent internal energy. And if we see the SI unit of internal energy, it is again a joule. So remember, these are the different characteristics aspects of the internal energy. Then we will see the sign convention of internal energy. How internal energy can be denoted with the help of sign. So let us say consider कि एक सिस्टम जो है उसका कन्वर्जन दूसरी सिस्टम में हो रहा है ड्यूरिंग अ केमिकल प्रोसेस. केमिकल प्रोसेस ज्यावेळेस होते त्यावेळेस सिस्टीम आपल्याला माहिती आहे की एका स्टेटमधनं दुसऱ्या स्टेटमध्ये जाते, बरोबर. पण ज्यावेळेस ती एका स्टेटमधनं दुसऱ्या स्टेटमध्ये जाते त्यावेळेस काय होत असणार आहे की दोन्ही स्टेटमध्ये इंटरनल एनर्जी ही सिस्टीमची वेगवेगळी असणार आहे. म्हणजे सुरुवातीला काहीतरी एक अमाऊंट असेल आणि फायनल काहीतरी अमाऊंट असेल, मग ती कमी असेल किंवा जास्त असेल. सो लेट अस कन्सिडर फर्स्ट द इनिशियल स्टेट. So we will say A is the initial state and B is the final state. Okay. So E1 is the internal energy of the system in initial state. That is also we can say whatever the reactant molecule which are present initially, they are having internal energy E1. 1 म्हणजे काय तर energy of the reactant किंवा initial state. E2 is the internal energy of the system in final state. That is product. Product ची जी एनर्जी असेल त्याला आपण काय म्हणणार E2. सो बेसिकली ज्यावेळेस आपल्याला इंटरनल एनर्जी कॅल्क्युलेट करायची असेल, म्हणजेच चेंज इन इंटरनल एनर्जी कॅल्क्युलेट करायची असेल, त्यावेळेस आपण काय करणार की इट इज द डिफरन्स बिटवीन फायनल स्टेट इंटू इनिशियल स्टेट. म्हणजेच आपण कसं लिहिणार ते डेल्टा ई. डेल्टा ई म्हणजे काय द चेंज इन इंटरनल एनर्जी इक्वल टू E2 म्हणजे इंटरनल एनर्जी इन फायनल स्टेट मायनस internal energy at initial state. So remember, this is a how we can represent. याच्यावरून आपल्याला काय काढता येऊ शकतं, ह्या जो क्वांटिटी आपल्याला E2 आणि E1 माहिती असतील जूल्समध्ये किंवा कॅलरीजमध्ये, तर आपण ते टाकून चेंज इन इंटरनल एनर्जी म्हणजे सिस्टीम ज्यावेळेस कन्वर्ट होते एका फॉर्ममधनं दुसऱ्या फॉर्ममध्ये त्यावेळेस चेंज इन इंटरनल एनर्जी किती असेल हे आपण कॅल्क्युलेट करू शकतो. आता आयदर ज्यावेळेस प्रोसेस होईल त्यावेळेस दोन प्रकार होऊ शकतात. एक्झोथर्मिक, ज्याला आपण काय म्हणतो की हीट इज इव्हॉल्व्ड ड्युरिंग प्रोसेस. इव्हॉल्व्ड म्हणजे काय हीट बाहेर टाकली जाते. बऱ्याच वेळेस आपल्याला असं जाणवतं बघा की कोणत्याही दोन आपण गोष्टी एकत्र केल्या तर आपल्याला जे भांडं आहे किंवा बिकर आहे ते आपल्याला असं गरम लागतं. फॉर एक्झाम्पल पाण्यामध्ये आपण सोडियम टाकला तर त्या केसमध्ये काय होणार आहे हीट एनर्जी इव्हॉल्व्ड होणार आहे. ओके. सो इन दॅट केस व्हॉट वी कॅन से द इंटरनल एनर्जी ऑफ ॲट इनिशियल स्टेट विल बी ग्रेटर दॅन इंटरनल एनर्जी ऑफ ॲट फायनल स्टेट. हिअर मस्ट बी E2. प्लीज करेक्ट इट. हिअर मस्ट बी E2. सो देन दिस पर्टिक्युलर डिफरन्स विल बी E2 minus 1. So this quantity will be higher than this one. Suppose this is a 20, this is a 20 and this is a 10. So 10 minus 20, so it will be minus 10. So that quantity will be negative. So when you say or when you see the delta E is having negative value, so what it indicate that the energy is given out from system into surrounding. System मधनं जी एनर्जी आहे ती सराउंडिंगमध्ये ट्रान्सफर झाली. त्याच्यामुळे काय होणार आहे जी एनर्जी आहे सुरुवातीची तिच्यापेक्षा एनर्जी सिस्टीमची कमी होणार आहे. सो एनर्जी विल डिक्रीज. सो रिमेंबर वेन E1 इज ग्रेटर दॅन E2 दॅट पर्टिक्युलर रिॲक्शन इज एक्झोथर्मिक. व्हायसे वर्सा इफ E2 इज ग्रेटर दॅन E1 म्हणजे ही क्वांटिटी मोठी आहे हिच्यापेक्षा, ही समजा 20 आहे आणि ही 10 आहे. सो 20 minus 10 is 10. So it is a plus quantity. So we can say this particular factor is a positive. So energy will be absorbed by system from its surrounding. म्हणजे सराउंडिंगमधनं एनर्जी ॲब्सॉर्ब केली जाईल सिस्टीमकडे, सराउंडिंगमधनं सिस्टीमकडे ट्रान्सफर होईल. सो याच्याने काय होणार आहे, प्लस म्हणजे काय होणार आहे, ॲडिशन होणार आहे, त्याच्यामुळे सिस्टीमची एनर्जी काय होणार आहे, वाढणार आहे. सो रिमेंबर इन केस ऑफ द एंडोथर्मिक रिॲक्शन देर इज अ increase in energy of the system. So remember there are very two important term. Now onwards we will talk in terms of exothermic reaction or endothermic reaction. So any particular reaction is suppose let us say exothermic. In that case you have to understood that E1 is greater than E2. So heat, in a case of the exothermic reaction, heat flows from system into surrounding. In case of the endothermic reaction, heat flows from surrounding into system. So remember these two terms, very important. Now we are going to see the very important law of thermodynamics, that is first law of thermodynamics. In short, if we say what first law of thermodynamics tells us, basically it tells us and it is related with the principle of conservation of energy. Conservation म्हणजे काय, एखाद्या पर्टिक्युलर एनर्जीचं दुसऱ्या फॉर्ममध्ये कन्वर्जन होणं सगळीकडे, सो पूर्णच्या पूर्ण. सो दिस इज कॉल्ड ॲज अ कन्झर्वेशन ऑफ एनर्जी. रिमेंबर फर्स्ट लॉ इज रिलेटेड विथ द प्रिन्सिपल ऑफ कन्झर्वेशन ऑफ एनर्जी. नाउ वी आर गोइंग टू सी द स्टेटमेंट्स. Different statements are there. So what are the different statements? You might be earlier classes you have studied. So energy can neither be created nor be destroyed, although it can be converted from one form into another. This is the first statement. So it is already being aware to us that energy नहीं कुछ हम लोग तैयार नहीं कर सकते, only we can transfer that particular energy from one form into another. एनर्जी आपण एका फॉर्ममधनं दुसऱ्या फॉर्ममध्ये कन्वर्ट करू शकतो. आपल्याला नवीन तयारी करता येत नाही आणि जी प्रेझेंट आहे युनिवर्समध्ये ती डिस्ट्रॉय करता येत नाही. समजा फॉर एक्झाम्पल तुमच्याकडे इलेक्ट्रिकल एनर्जी आहे तर तिचं कन्वर्जन तुम्हाला मेकॅनिकल एनर्जीमध्ये करता येईल. सेकंड स्टेटमेंट, व्हेन एव्हर अ क्वांटिटी ऑफ वन काइंड ऑफ एनर्जी इज प्रोड्यूस्ड अँड एक्झॅक्टली इक्विव्हॅलंट अमाऊंट ऑफ अनदर काइंड ऑफ एनर्जी disappears. So what does it means? When one kind of energy is produced, suppose if you have produced some electrical energy, so exactly what kind of another form of energy is being disappears because it is being converted from one form into another. So what will happen when first form of energy get converted into second form? Ultimately first form get disappears because all the energy is utilized for carrying out next particular form of energy. Then third statement, very important, the total energy of the universe is constant. This is a very important statement. So whatever the energy we are having, that is being constant inside the universe. So energy of an isolated system remains constant, that is delta E. Isolated system, neither energy flows nor the matter. So this is a isolated system. So remember this particular statements. Now we are going to see what is a mathematical derivation for first law of thermodynamics. So remember we have to derive the mathematical expression for the first law of thermodynamics. So for that we will see one particular setup. This is a container which is being enclosed with the gas molecules and having a fitted with frictionless piston, so that can move upward or downward. So this is these are the molecules which are being present initially. So what will happen? This is the initial state, this is the final state. Suppose आपण कंटेनर मध्ये एक गॅस एन्क्लोज केला आहे, तो पर्टिक्युलर गॅस जो आहे that is being trapped inside the container and that container is having frictionless piston that can move upward and downward during the process of compression and expansion. सो आता अशी जर सिस्टीम असेल ॲट इनिशियल कंडिशन, सपोज ह्या सिस्टीमला नी काहीतरी वर्क केलं आणि काय होऊ शकतं, आयदर सपोज आपण हीट प्रोव्हाइड केली तर काय होणार आहे, गॅस मॉलिक्युल एनर्जाइज होतील, आयदर प्रोसेस होईल एक्सपान्शनचे किंवा कॉम्प्रेशनचे. ओके, आता आपण असं करूया की ही जी सिस्टीम आहे तिला स्वतःची इंटरनल एनर्जी असणार सुरुवातीला, दॅट विल बी E1. सपोज त्याच्यावरती आपण प्रेशर अप्लाय केलं तर काय होईल, तर पिस्टन आपण वरून पुश केला तर काय होणार आहे, जो इनिशियल व्हॉल्यूम असेल तो कमी होईल. सो अल्टिमेटली व्हॉल्यूम विल गेट डिक्रीज अँड प्रेशर विल गेट इन्क्रीज. So these are the terms we are know. So let us say this is a particular system. So E1 we will say ह्या ज्या सिस्टीमची इनिशियल एनर्जी आहे ती E1 आहे असं कन्सिडर करू ॲट इनिशियल स्टेट. 1 म्हणजे काय, इनिशियल स्टेट. सपोज दॅट पर्टिक्युलर सिस्टीम ॲब्सॉर्ब अन अमाउंट ऑफ हीट, देन इंटरनल एनर्जी विल बी E1 प्लस Q. सपोज वो जो सिस्टम है दैट विल एब्सॉर्ब अ क्वांटिटी ऑफ हीट फ्रॉम सराउंडिंग. So as a result of that, what will happen? The energy of that particular system will get increase. So initial energy is E1. So this is a E1, and whatever the quantity of heat absorbed will be that. So that particular internal energy will be right now E1 plus Q. So when this particular system absorb heat, then there is a very important phenomena is going to happen. The system is going to perform work W. As we know that when heat flows, it results into the generation of work. So ultimately what will happen, the internal energy will be E2 right now in the final step. यहाँ पे हम लोग जब देखेंगे तो उसकी एनर्जी इंटरनल एनर्जी कितनी होगी, E2 होगी. सो E2 विल बी इक्वल टू व्हाट, यहाँ पे इनिशियल एनर्जी प्लस Q which is being absorbed and whatever the work done. So that will be equal to internal energy, that is E2. E2 is nothing but internal energy in the final step. अगर ये जो इक्वेशन है इसको हम लोग ये टर्म राइट साइड से लेफ्ट साइड लेके जाएंगे तो क्या होगा, इट विल बिकम E2 माइनस E1 इक्वल टू Q प्लस W. बट वी नो दैट दिस पर्टिकुलर टर्म E2 माइनस E1 we can write in this particular format, डेल्टा E. ये जो टर्म है वी कैन राइट इन द फॉर्म ऑफ डेल्टा E. डेल्टा इज नथिंग बट व्हाट, चेंज इन इंटरनल एनर्जी फ्रॉम फाइनल स्टेट माइनस चेंज इन एनर्जी इन इनिशियल स्टेट. सो क्या हो जाएगा, डेल्टा E इक्वल टू Q प्लस W, बिकॉज डेल्टा E इज इक्वल टू E2 माइनस E1. W we can write as P delta V also, minus P delta V, because that is being work done. Work done is equal to force into displacement. In the case, what is the force? Your pressure. And what is the change? Volume. So this is a equation of first law of thermodynamics. What is the equation? Delta E is equal to Q plus W. This is a mathematical expression of first law of thermodynamics. So it is nothing but change in internal energy of a thermodynamic system is equal to amount of energy, heat energy which is added, plus work done on the system or by the system. So this particular W sign either will be plus or it will be also minus. It will depend upon whether that particular process is in the form of work is done on the system or work is done by the system. So that is either it is a compression process or expansion process. If we see this particular process, it is a compression or expansion, it is a compression. Okay, so it is we have done work done on the system, so that will be plus. So remember, delta E is equal to Q plus W is the mathematical derivation of first law of thermodynamics. Now we are going to see some limitations of first law of thermodynamics. After it is being postulated, there are some drawbacks what other scientists have been found. The first drawback is that it does not talk about the direction of flow of heat. So if you see the mathematical derivation, there is no clear-cut indication about the flow of heat, whether that flow from system into surrounding or surrounding into system. There is no clear-cut indication. So it does not define ease or extent of energy conservation from one form into another. With this particular expression, we cannot define ease or extent of energy conversion. So this is being failure. Then it also cannot explain why natural processes are unidirectional. नेचर में जो प्रोसेस होती है वो यूनिडायरेक्शनल मीन्स इरिवर्सिबल क्यों होती है ये नहीं बता सकते. पानी ऊपर से हायर लेवल टू लोअर लेवल क्यों गिरता है? वाई हीट फ्लो फ्रॉम ऑलवेज हॉटर बॉडी टू कोल्डर बॉडी? सो दैट कैनॉट बी एक्सप्लेन. It does not say whether heat change is endothermic or exothermic. Then it also cannot explain why practically it is not possible to convert heat energy into equivalent amount of work. जो भी एनर्जी अवेलेबल होती है वो पूरी की पूरी वर्क करने में क्यों नहीं कन्वर्ट होती, ये नहीं बता पाया फर्स्ट लॉ ऑफ थर्मोडायनामिक्स. सो दीज आर द ड्रॉबैक्स और लिमिटेशन व्हाट वी कैन से विच आर एसोसिएटेड विद द फर्स्ट लॉ ऑफ थर्मोडायनामिक्स. Before we end, we will understand some basic terms. Till now we understood term heat, which is being denoted by sign Q, then work, which is being denoted by sign capital W, then E, internal energy. These are the three basic terms which are till now we are understood: heat, work and internal energy. So based upon the whatever the process takes place inside the system into, so that particular these three terms will have the different sign, either it will be plus or minus. So remember, when we say plus Q, that is positive, so heat flows from surrounding into system. Addition of energy, plus Q, heat energy, minus Q, negative. So what does it explain? System मधनं एनर्जी सराउंडिंगमध्ये ट्रान्सफर झाली किंवा फ्लो झाली. W इज पॉझिटिव्ह. W पॉझिटिव्ह कधी असेल? वर्क इज डन ऑन द सिस्टीम. रिमेंबर द वर्ड्स ऑन अँड बाय. ऑन द सिस्टीम म्हणजे काय? कॉम्प्रेशन. आपण स्वतः काहीतरी काम केलं. वी हॅव पुश्ड द पिस्टन, सो वी हॅव अप्लाइड द प्रेशर. W negative means what? Expansion process. Suppose delta E is having negative value. So that particular process is exothermic or endothermic? It is exo. निगेटिव्ह म्हणजे काय? बाहेर जाणे, बाहेर पडणे. सिस्टीममधनं हीट बाहेर पडणार आहे. सो दॅट इज अ एक्झोथर्मिक रिॲक्शन. अँड सपोज इफ यू हॅव द डेल्टा ई पॉझिटिव्ह व्हॅल्यू, so that particular process will be endothermic. So remember, these are the three basic sign convention which you need to remember in order to understand the different terms which are related with the. And if you see the first law of thermodynamics, it is having all these three terms: internal energy, heat and work. So remember this mathematical equation: delta E is equal to Q plus W. W will either have plus or minus sign, remember. So go through this particular part what we have till now covered. These are the very important part which will help us in order to understand the next concept related in the chemical thermometer. Thank you very much. See you in the next sessions.